All right, well, welcome back. Here we go. Here's another cool solving for x, solving for the variables here. Example number 3 out of the 6-part series of how to solve for x. All right, so in this example, we're going to solve this, and we're going to use our inverse operations. We got another value inside. We're going to solve for x here. We got another square, all this cool stuff. So the first thing we're going to do is we're going to add all our values. We can get x by itself, so we're going to add 1 to both sides. So we have cosine squared of 4x. All right, and we have our 2 right there, and it's going to equal 1. We're going to divide by 2 here, all right, or multiply by 1/2. Multiply by 1/2 right there. So now we have cosine of 4x, that quantity is going to be squared. All right, remember that right there means the whole correct quantity is squared, and we're going to have equals 1/2. From here, what we're going to do next is we're going to take this. And so now what we're going to do is we're going to take this and we're going to take the square root. All right. So from here, we're going to take the square root. And when we do that to both sides, I already did that by itself. Remember, we have to bring the plus or minus because we both have a positive and negative value we can have there. So like my previous problem, example number 2, if you saw that other video, is we're going to create 2 different solutions we can have. I'm going to have this right side, we're going to have cosine of 4x, and I'll make this the positive one. So the square root of 1/2. And on this other side, okay, we're going to have cosine of 4x. That's going to equal the negative square root of 1/2. Okay, so we have those 2 different solutions that we need to try to solve for now. Now from here, we're going to solve this. So we have cosine of 4x. And I'm going to simplify this to the square root of 1, which is 1, over the square root of 2. Now, you might be familiar with this. Now, not all the problems in the first 3 examples, they're all basic ratios that we should know. All right, 1 over the square root of 2, that is a basic ratio of a 45, 90-degree triangle. Hopefully, you know that. 1 or square root of 2 over 2. All right, if we simplify that. But in any case, now we want to solve for 4x. So how do we get rid of cosine? We do not divide by cosine. We do not divide by cosine. But instead, we have to use the inverse operation, right? The inverse operation. So we're going to do the inverse here. All right, our inverse operation, I'm just going to write that down, just so you guys remember, inverse operations. All right, that is so important, so important. All right, so we're going to take this, and we're going to take the inverse, all right, so inverse cosine of both sides. And when we do that, we get the inside, so the cosines cancel out, all right, so we have the inverse cosine of 1 over the square root of 2. All right, and what we have then is 4x equals the inverse cosine of 1 over the square root of 2. Now, from here, we have to figure out what are these values going to be. Now, we're going to figure this out from 0 to 2 pi, 0 to 2 pi. So if I do this right here, cosine, now this ratio right here, because remember we're doing inverse, we find an angle. So we're trying to find an angle that will give us the ratio of 1 over the square root of 2. Well, that's a 45-degree angle. But where is cosine positive? Well, cosine is positive in the first quadrant and also in the fourth quadrant. All right. So cosine is positive. And how do I know it's cosine positive? Because the ratio inside here is positive. So I have a ratio of 1 and then the square root of 2. All right. So it's going to be 1 to the 1 to the radical 2. Come on now. All right. That's a little song, a little ditty that I make up. All right, for my classes. But what we have, this is going to be a 45, 90-degree right isosceles. So 45-degree angle, so we have 4x is going to equal 45 degrees, at least for this first quadrant. And when we go all the way around to the fourth quadrant, we'll also have 4x, and that's going to equal, all right, 315 degrees, all right? Or we know it's going to be pi over 4, or I'm going to put this in radians. This is going to be 7 pi over 4 in the fourth quadrant, and we have that. Now, for this, remember that we also can have, because yes, this is our first, all right, from 0 to 2 pi, but we can find coterminal angles. Because if I go here and go all the way around back over here, how do we find a coterminal angle? All right, coterminal. Remember, coterminal. All right, coterminal angles are ones that when you add 2 pi, all right, when you add 2 pi to them, or 360 degrees, you get another angle that matches it. All right, and that's where we're going to find. Now, we're going to find all of them, so I'm going to put an n here, all right, right there, where n means any integer. So if I add 1 here, it would be just 1 2 pi, or it could be 0, 2. All right, our negative integer, whatnot, and we'll go backwards, but I would always get that answer. So there's many solutions to this because we don't have a restriction of just going from 0 to pi. All right, so now that would be our answer if we just stop there. All right, but now we want to take this and actually solve for x now. So we have one last thing is we're going to take this and now divide this whole thing by 1/4. All right, we're going to divide this whole thing by 1/4. Now, when we divide this whole thing by 1/4, obviously this is going to turn to x. So we have now x is going to equal, we're going to take 45 divided by 4, but I'm just going to not do that. I'm going to just keep this right here. So it makes it a little bit easier. Here we have pi over 16 plus, and now I want to divide this by 4. I'll have 2 pi n over 4, which then, you know, the 2's and the 4 cancel out. I'm left with pi over 2 n. Okay, so that means I'm actually adding a 90-degree angle, or pi over 2, to every pi over 16. All right, and that is going to be one of my solutions. One of my solutions there. We're going to do the same thing for this bottom one right here. So we have x is going to equal, I'm just not going to turn up degrees right now because it's there. All right, so we're just going to take 7 pi over, once again, 16. And if I divide the 4 into here, 2 pi divided by 4, once again, is pi over 2 n, and that is going to be our other solution. All right, for at least the positive realm. All right, so that was cool. So that was 2 of our solutions, but remember, we're not done yet because we also have the negative portion over here that I have to finish up. So we're going to do this negative portion. Okay, doing this, solving for x, I'm going to take the inverse cosine. All right, remember to take the inverse cosine of both sides to get rid of the cosine, so we can solve for the inside of cosine. All right, I have negative, all right, our inverse cosine of now the quantity negative 1 over the square root of 2. All right, and so now we have 4x because these will cancel out. We're left with the inside 4x, which is going to be the inverse cosine of negative 1 over the square root of 2. Now, cosine, where is cosine negative? Well, cosine, if you recall, is going to be negative, all right, where x is negative, and it's going to be in the second quadrant and also the third quadrant. So we're talking about these 2 angles right there, that one, and then the one right there, going like so. Well, once again, our reference angle is going to be that 45-degree angle, all right, because we have negative 1 right, not the angle in there. What am I doing? Not good. All right, but we have negative 1 there because it's adjacent, right? And we have our square root of 2 and the square root of 2. All right, so we have that right there. Okay, and so what we have then is going to be in the second quadrant and the third quadrant. So what is that value going to be? Well, it should, all right, going to be, well, it's going to be 3 pi over 4, all right, or 135 degrees. All right, so that's going to equal 4x. And then we have another one in here, which is going to be 5 pi's over 4. It's going to equal 4x. Now recall, once again, just like over here, we have to add in all the coterminal values that we have here. So we're going to add in 2 pi n, and we're going to add in 2 pi n, just like the previous ones. But just like the other ones, we have to divide now all of this, even the coterminal angles, by 1 over 4. So don't forget your coterminal angles. Don't forget the inverse operations, and don't forget coterminal angles. All right. So we're going to do both of these by 1/4. So what is our final answers? Well, we have then an answer of x is going to equal, all right, 3 pi over 16 plus, once again, divide this by, we have pi over 2 n, and this one right here is going to be 5 pi over 16 plus, once again, divide by 4, and we have pi over 2n. And so right there, how many different solutions do we have? Well, 1, 2, 3, 4. 1 for the positive, 1 for the negative, and that is what we have. So, yes, solving trig functions can be a lot of work, especially if you do it by hand without a calculator. But not too bad. Once again, what are we doing? We're just doing inverse operations. Once we have this, then we're solving. Just remember when you take the square root, you have a positive and negative solutions. When you have this, make sure you use the inverse operation. Don't divide by cosine, but use the inverse operation to solve for it. You got to know your basic trig bits to solve that. Okay. right here, inverse cosine of 1 over square root of 2, or inverse cosine of negative 1 over square root of 2. You find out your basic locations. Make sure you add your coterminal angles if they don't give you any restrictions on the domain. And then, once again, solve for x by dividing finally through by whatever the value is here. All right. Well, that is the end of our example number 3. And I'll have 3 more examples on some upcoming videos. All right. Well, good luck. God bless on the rest of your problem.